Right. Now I think I send now. I send the page through that PDF. Then we are discussing circular motion questions. Circular motion past paper MCQ. Circular motion past paper MCQs. I don't know how many of you tried them. I don't know how many of you tried them. Circular motion past paper MCQs. Circular motion. Uh, circular motion. Circular motion MCQs. 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 Right. Okay. Now 1990 A level. Sorry, 1998 A level. Question number one. 1998 A level. Right. First one. 1998. 1998 A level. First one. Right. 1998 A level. Right. A particle moving in a circle of radius 2 meters. Particle moving in a circle of radius 2 meter at constant speed has a period of rotation 2 seconds. Right? Its acceleration to the center of the circle is acceleration to the center of the circle is. Now there's a particle. That particle moving in a circular motion. They have given the radius. Look at it. Circular motion. The particle. Now this MCQ is very easy MCQ. It's not difficult MCQ. It's a very easy MCQs. Yeah. Right. Right. Now let's say now this is our center point capital O, center. Now particle moving in a circular motion. Now we know that always in circular motion questions, we apply F equals ME. We consider the circular motion and we apply F equals ME. What is the main characteristic of circular motion? The main characteristic of circular motion. Now always, if an object moving in a circular motion, always the main characteristic. Tangential velocity always perpendicular to centripetal force, centripetal acceleration. We learned something like that. And remember, we learned circular motion questions. We learned that. We learned when this particle, let's say mass simple limb, when this particle moves in a circular motion, the orbit, the radius of the circular path, let's say capital R, if not simple R, tangential velocity at this instant, capital V. I hope you know what's tangential velocity. Angular velocity, let's say omega, angular velocity omega. Then the main important characteristic of circular motion is always tangential velocity perpendicular to centripetal force. Always tangential velocity perpendicular to centripetal force. Tangential velocity perpendicular to centripetal force. Right? Centripetal velocity, the important characteristic of circular motion. Now, what is the important characteristic of simple harmonic motion? In simple harmonic motion, always acceleration directly proportional to displacement, always acceleration toward the center. That is the main characteristic of simple harmonic motion. Then what is the important characteristic of circular motion? Always tangential velocity perpendicular to centripetal force. If not, we can say centripetal acceleration. Ne? Tangential velocity perpendicular to centripetal force. If not centripetal acceleration, centripetal acceleration. Then can you remember we derived two equations for centripetal acceleration. Centripetal acceleration can be written as r omega squared. If not, centripetal acceleration can be written as v squared, tangential velocity squared over r. Then what is the relationship between velocity, radius, and angular velocity? Tangential velocity is v, radius simple r, angular velocity omega. We know that v equals r omega equation. V equals r omega equation. Whenever angular velocity, if they have given time period, always understand circular motion questions, if they give time period, then understand if you know time period means you know omega. In a day kind of question, if they gave time period, then you can say that you know omega because we know omega equals, so time period equals 2 pi over omega. Then omega equals 2 pi over t. So therefore understand a question if they have given time period, always understand, then you know omega. Angular velocity, time period equals 2 pi over omega. Some important equations. Now here, tangential velocity. Now this question says, particle moving in a circle of radius 2 meters. If you can do this question, you do, right? You do it. While I explain, if you feel that you can do this question, you do it. A particle moving in a circle of radius 2 meters, constant speed has a time period of 2 seconds. Radius simple r, we know radius simple r. Radius, how much radius? We know 2 meters, something else. Radius 2 meters. Radius 2 meters. And we know that time period. They have given time period. Radius given 2 meters and the time period given 2 seconds. Time period 2 seconds. Acceleration to the center. That means centripetal acceleration. Now, centripetal acceleration. It's lagging. It's lagging. Someone reply it's lagging. Is it lagging? Others? It's lagging right now. Reply, everyone, reply quickly. Don't waste the time. Reply. If I ask now, think that it's a one-to-one session. It's a one-to-one session, right? Now you can see me, but I can't see you, but you can see me. In it's one-to-one session. If I ask question, there are some students every time they reply, but some students they don't reply because you think that others reply because of others reply. If you don't reply, it's a problem. Then without considering anyone, I just keep on explaining. Even it's lagging or not lagging, I don't mind. Okay, someone reply it's lagging quickly. Don't waste my time. And I don't give the recording for today's class. Right, okay. Then we know that now. They're asking centripetal acceleration to the center. Centripetal acceleration to the center. Centripetal acceleration means, now what is the best equation? Centripetal acceleration, we can write down r omega squared equation. If not, we can go with v squared over r. But as they have given the time period, it would be better that if you go with centripetal acceleration equals r omega squared. Do you understand? You can go with r omega squared equation. R omega squared equation. A equals R omega squared equation. Then we can say that centripetal acceleration. What defines centripetal acceleration is centripetal acceleration equals now R. We know R. We know omega means what? T equals 2 pi over omega. Omega means 2 pi over capital T. 2 pi over capital T squared. Omega means 2 pi over capital T whole square. That means 4 pi squared over capital T squared. Now when you substitute, we are getting a radius simple R is 2 meters, and 4 5 squared. Time period is 2 seconds. 2 squared means again 4. Then 4 cancel out. Then centripetal acceleration will be 2 pi. Centripetal acceleration will be 2 pi squared. Right? Then you know what is the answer. Then 1999 1999 1999 1999 Two particles capital A and capital B are moving in concentric circles of radii RA/RB. There are two particles. They move in concentric circles radii RA and RB such that their periods of rotation are same. Now there are two particles capital A and capital B. There are two particles capital A and capital B. Right? There are two particles capital A and capital B. Both the particles move in two different circular motions. But the thing is, time period of particle A and time period of particle B both are same. Then you want to understand if their time period same, their angular velocity same. If their time period same, then their angular velocity is also same. Omega also same, right? If their time period same, then their angular velocity is also same because we know that time period equals 2 phi over angular velocity omega. T equals 2 phi over omega. If both of them have same time period, that means their angular velocity also same. That idea, right? Uh, they're asking ratio centripetal acceleration of particle A over centripetal acceleration of particle capital B. Then we need to find centripetal acceleration of capital A particle. I say that centripetal acceleration of capital A particle, A capital A, centripetal acceleration of particle capital B. Then you need to find its ratio. You need to find the ratio of centripetal accelerations. Right? Now, very easy. Sometimes these are MCQs. Now, allocated time for one MCQ is 3 minutes, right? We take roughly 3 minutes, 2.5 minutes to do one MCQ. Now, this type of MCQ is very easy. Now, we know that now. We need to find centripetal acceleration ratios. Then we know centripetal acceleration means R omega squared, if not V squared over R. Now, which is the best equation? The best equation is centripetal acceleration because now they mention time periods are same. Therefore, we can say that angular velocity of particle A and angular velocity of particle B both are same. And then omega same. Then what is the best equation to find centripetal acceleration? Centripetal acceleration equals R omega squared. In that equation, centripetal acceleration equals R omega squared. We know that omega is same for both the particles. Angular velocity of particle A and particle B both are same. Therefore, we can directly say that centripetal acceleration directly proportional to radius. Centripetal acceleration directly proportional to radius. So therefore, we can say centripetal acceleration of capital A particle directly proportional to radius of the circular path RA. Radius of the circular path RA. Proportionality 1. But when I do the MCQ, we can directly say centripetal acceleration ratio equal to RA over RB. RA over RB because, but I take some time and I explain, but when you do MCQs, you should not write down all these steps. After you understood the equation for centripetal acceleration is A equals r omega squared, with your mind you can say that omega is constant for both of them. Then we can say centripetal acceleration directly proportional to simple r. Acceleration ratio means AA over AB equals RA over RB. That knowledge you must have. RB. Then we can say that centripetal acceleration ratio equals, if I divide proportionality 1 by proportionality 2. When we divide proportionality 1 by proportionality 2, what will happen? Proportionality will become symbol equation RB. Raise your hands if you understood. Raise your hands if you understood. A small mass is kept. Now this is a very important thing. A small mass is now, next question, 1999 11. 1999 11. 1999 11. Next one. 1999 11. Next one is also. A small mass is kept on a horizontal circular table which can rotate about a vertical axis, passing through a center of the table. The mass starts to slip when the angular velocity of the table becomes omega. This is very important. The mass starts to slip when the angular velocity of the table becomes omega. If the distance to the mass from the center of the table is doubled, the minimum angular velocity required for the mass to start slipping. Right? The table. Just think about your table. It's your table. The axis. Okay. Now table is rotating. Table is rotating. Table is rotating. Then let's say now there's an object. Or let's say now this is the center of the circular table. Now table is rotating. Now here is our object. Is our object. Right. When table rotates, this object moves in a circular motion. When table rotates, this object moves in a circular motion. And now, right. So when someone looks from the top view would be, when someone looks from the top, how would the top be? The top view. When someone looks from the top view would be like this. Circular, circle, center, capital O is our object. It is our object. This object moves in a circular motion. 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 Right, okay. Now the main requirement for a object to move in a circular motion, there must be a centripetal force. I hope you can remember what is centripetal force. Centripetal force means the resultant force acting to the center. That is what we call a centripetal force. Then can you remember I explained that centripetal force is provided by different types of forces. Now reply that in this particular scenario. Now when you place an object on the table, when that table rotates, when you place an object on the table, when that table rotates, in order to move the object in a circular motion, which force produces the centripetal force? Reply in chat box which force acting on the object produces the centripetal force. What is the force acts as the centripetal force on the object? That is friction force. That is friction force. That is friction force, right? Now we know friction force. Now we know that. Now what's happening now? Just think about now this. Now just think about this table is rotating with an angular velocity of omega. Now this, let's say this omega is 10 radians per second. This omega is 10 radians per second, right? Then what happens? Due to the rotational speed of the table, what happens actually? This object placed on the table tends to slip away from the table. When this table is rotating, this object tends to move away from the center of the table. Do you understand? Now, normally you might have that experience, right? When you keep an object on a rotating something and when you rotate that particular table or whatever, what would happen? That object tends to move away from the, it tend to slip away from the table. So therefore, this object is also tends to move away from the table. That means move away from the center of the table. Then when this object tends to move away from the table, there will be frictional forces on the object to resist the motion. Now this object tends to slip away from the table. This object tends to slip away from the table, and then there will be a friction force acting on the object to resist the slip. So therefore, friction forces acting on the object towards the center. Frictional force Ff. Frictional force Ff. Frictional force Ff. Now I'll ask a question. Now what would happen for this frictional force? Now we know that, very carefully listen, this is very important. I take some time and I explain this idea. This idea is very important. I take time and I'll explain this idea is very important. Now we know that in a circular motion, if an object is to be moved in a circular motion, there must be a centripetal force acting on the object. If there is a centripetal force on the object only, we know that that object will move in a circular motion. We know that idea. Now, I need an answer from you. What will happen that if the angular velocity of the object increases, if the angular radius is constant, that object is moving under same radius, that object is moving in a circular motion but by having same radius, but what happens? Angular velocity of that object increases. If the angular velocity of that object increases, in order to maintain the circular motion, what should happen? When object's angular velocity increases, in order to maintain that circular motion, what should happen? Reply. 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 Now angular velocity is increasing. If omega increases, in order to maintain the circular motion, what should happen? What should happen? Centripetal force must be also increased. Why? When angular velocity increases, very carefully listen, when angular velocity of the table, if not when the angular velocity of the object moving in a circular motion increases, relative to that, centripetal force to the center must be increased. Why? Centripetal force equals mass into r omega squared. This capital F means centripetal force, Fc. Fc equals centripetal force mr omega squared. When angular velocity increases, relative to that, understand, in order to maintain the same circular motion, centripetal force must be increased. Did you understand? Then this scenario, for this example, which force acts as centripetal force? Friction force. We know that friction force acts as centripetal force. Now, when the angular velocity increases, we know that in order to maintain the same circular motion, centripetal force must be increased. Therefore, we know that when omega increases, frictional force must be increased. And then we know that frictional force starts from 0 Newton. If frictional force can be increased, the maximum possible frictional force belongs to static frictional force, FF, equals mu r, right? Beyond that, frictional force cannot be increased, right? Then, let's say now someone is increasing angular velocity. Very carefully listen. Very carefully listen. This is very important. It's very important. Let's say someone is increasing angular velocity. When someone increases angular velocity, in order to maintain the same circular motion, centripetal force must also be increased. 10 radian, 5 Newton. 10 radian, 10 Newton. Likewise, when omega increases relative to that, centripetal force must be increased. Now, who produces centripetal force? The centripetal force is provided by frictional force. Centripetal force provided by frictional force. That means frictional force also increases, but there is a limitation. Because friction force can be increased up to a certain limit. Now you keep on increasing omega. You keep on increasing the omega relative to that frictional force also increases. And frictional forces becomes its maximum frictional force. We call it as static frictional force. In case that when the moment, let's say when the moment frictional force becomes static frictional forces, that is maximum friction force. When friction force becomes maximum frictional force, angular velocity is omega. When someone tries to increase omega further, this object will not move in a circular motion. Why? The maximum possible friction force is static friction force. If you increase omega further, this object needs larger centripetal force to maintain circular motion. Who produces the centripetal force? Friction force, but this time friction force is not able to increase its force. Why? Friction force has reached its maximum frictional force. So therefore understand, after a particular value, the max at the maximum omega, when this table rotates with its maximum omega, when this table rotates with its maximum omega, frictional force acting on the object is maximum. Did you understand? The maximum friction force is a constant, so limiting friction force, right? Limiting static limiting friction force, right? Raise your hands. After everything is very clear. After everything is very clear, right? Then we can say that now they are asking something else. Now they say that now when the object is now in this scenario, now when we read the question, small mass is kept on a horizontal circular table which can rotate about a vertical axis passing through the center of the table. The mass starts to slip when the angular velocity of the table becomes omega. That means when the angular velocity becomes omega, the friction force acting on the object is maximum. When you slightly increase omega, what would happen? Object will continuously slip away and leave the table, right? Then exactly at that omega value, friction force acting on the object is maximum, right? Then they say that the mass starts to slip when the angular velocity of the table becomes omega. If the distance to the mass from the center of the table is doubled, minimum angular velocity required for the mass to start slipping is very easy. Now, even though I explained some time, but you can easily get the answer now. We know that centripetal acceleration is friction. Now for this scenario, let's say when the distance is simple r, when you consider the radius, the circular motion, the radius is simple r. If it's a simple r, then we can say that, we can say frictional force is a constant if mass simple m, radius simple r, and corresponding angular velocity omega square. Equation 1. Even when you double the radius, when now again you rotate. If not again you rotate the table by placing the object at a distance 2 simple r from the point capital O. Now radius of the circular path is doubled, but even so, maximum friction force is same. Same maximum friction force, same maximum friction force, same mass. Now radius double, therefore 2r. Radius double, therefore 2r. Now let's say now angular velocity is omega 1. Now angular velocity is omega 1. Omega 1. Omega 1 square. Now you need to find omega 1 in terms of omega. Then when you divide equation 1 by 2, when you divide equation 1 by 2, you will obtain that. Sorry, if you divide equation 2 by 1, you will obtain that. You can say that omega 1 squared now. Now there are different ways of simplifying these steps. Different ways of simplifying this. Now we can say that m into 2r omega 1 squared. M into 2r omega 1 squared over mr omega squared equals f over f. F cancel out, r cancel out. Somehow omega 1 will be omega over root 2. Somehow omega 1 will be omega over root 2. That is your answer. That is your answer. Right. Then third one is also done. Then we'll discuss question number again, sixth one. 2001 A level. 2001 A level. 2001 A level. 2001 A level question. 2001 A level. In this case, sixth one. A child of mass 20 kilogram is sitting on a swing of negligible mass. Sitting on a swing of negligible mass. The swing is attached to its pivot by 2 ropes, each of 3-meter length. The swing is attached to its pivot by 2 ropes, each of 3-meter length. The maximum speed of the child during a swing is found to be 3 ms minus 1. Maximum tension force in each rope. Now on chillawak near swing. Now there's a swing, right? Something like this. If I draw a sketch, a swing. Now the swing is pivoted by using 2 ropes. Using 2 ropes, right? One rope, the second rope. Two ropes. Okay. Then the child is sitting on this swing. Then when you mark the forces, if you mark the forces, just think about now. What happens? We can say that this swing moves in a circular motion, not a complete circular motion, but this swing a partial. The swing moves in a partial circular motion. We can say like that. It's not completely moving in a circular motion, but a partial circular motion. We can say that it's moving in a circular motion, right? Some sort of circular motion, like this. It's moving in a circular motion. Then shall we mark the forces? When you mark the forces, look at it. If I mark the forces, when I mark the forces, when I consider top wave, not top wave, side wave, but front wave. If I consider front wave of this swing, but not necessary to draw all these things. If you can imagine the forces, then that's fine. Tension forces on the swing, capital T tension forces on the swing. There are 2 ropes. So therefore, there are 2 tensional forces. Then the person is here. Here is our person. Is our person. Then when you mark the forces, weight of the person W. Weight of the person W. Normal reaction force on the person R upwards. Normal reaction force on the swing R downwards. When you consider entire system, swing with the person, swing with the child, capital R cancel out. Then there are, what is the resultant force? If you say the center is here, resultant force acting to the center is 2 capital T minus W. Okay? Resultant force. This is your center. Center is your system. Then tension force is 2 capital T and weight force is W downward direction. Weight is W. Then what is the resultant force acting to the center? Resultant force to the center is 2 capital T minus W. It's this system, the child with the swing moves in a circular motion, some sort of partial circular motion. Some sort of circular motion. Right? Circular motion. Then they are asking what is the maximum tension force acting on each rope. They are asking maximum tension force acting on each rope. Then I can apply usually all the questions we apply F equals MA, and we can apply F equals MA. F equals MA. Now centripetal, now here F means centripetal force, M mass, centripetal acceleration. I can write down centripetal acceleration as given data. Have they given maximum velocity? They mention mass is 20 kilograms and they mention the length. That means radius 3 meters. The length of each rope is 3 meters. That means the radius of the circular motion is also equal to length of the rope. Therefore 3 meters. Maximum speed is given 3 ms minus 1. Therefore, it would be better that if we can go with mv squared over r, centripetal acceleration. Now this time, as they have given velocity, maximum velocity, I thought to go with v squared over r. Do you understand? So then, centripetal force equals mass into centripetal acceleration. That means v squared over r. Now, which force acts as the centripetal force? 2t minus w. Not 2t, but not w, but 2t minus w. The resultant force to the center. The resultant force to the center is 2 capital T minus w. 2t minus w. 2t minus w. Look at it. 2t minus w equals mv squared over r. Now you can clearly understand mass, weight, distance, sorry, mass, weight, radius. That means length of the rope or a constant. When velocity is maximum, tension is maximum, right? When velocity is maximum, tension is maximum. Did you understand? Now, if I subject tension, okay, if I subject tension force, tension equals, I can say tension equals m v squared, tension equals mv squared over r. If I divide all terms by 2, it's 2r, mv squared over 2r plus w2 plus w2. Then, when velocity is maximum, tension force is maximum. The maximum tension force on the rope equals uh, mass is they mentioned mass is 20. Mass is 20. Velocity is 3 squared. 3 squared is 9. Velocity is 3 squared. What is the length of the rope? It's 3 meters. 3 meters. Again, weight means mg. Weight means mg. 20 into 10 over 2. Then we'll end up with here 1 3 1 3 cancel out. Here it's 60 over 2 means 30. It's 30 plus 200 100. Then 130 newtons. 130 newtons. T max. T max 130 newtons. Then 2003 A level. 2003 A level. 2003 A level. Right? Now, that question. A toy car connected to a fixed point by an elastic string as shown in the figure. A toy car connected to a fixed point by an elastic string as shown in the figure travels in a horizontal circle of radius 2 simple r. Travels in a horizontal circle of radius 2 simple r. The initial unstretched length means natural length. The natural length of the elastic string is simple r. The period of rotation of the car is capital T. Right. 2003 level. Look at it. 2003 level. This time. 2003 level. Right. Now, let's say now natural length of a string is simple L, simple R. In that question, question number seventh one, string natural length. When the string is under natural length, its length is simple L. Let is simple L. When 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 we connect a mass to one end of the string, when the toy car is connected to one of the ends of the string, and when that toy car with the string moves in a circular motion, its radius is 2r. When that when the toy car connected to one of the ends of the string, when the toy car moves a circular motion, its radius 2 simple r. Natural length is simple r, radius 2 simple r. Natural length simple r, it has stretched simple r, right? When that vehicle moves in a circular motion, very carefully. When that toy car moves in a circular motion, when this toy car moves in a circular motion, this string has stretched simple r distance, right? Because why? Because we know that now when an object is to be moved in a circular motion, there must be a centripetal force. Now this time, how this string connected to a car produce the centripetal force? By stretching itself. When that string stretches itself, there will be a tension force in this direction. Tension force. Because of the tension force, as this string stretches, because of the tension force, this toy car moves in a circular motion. They mentioned time period is capital T. They mentioned time period is capital T. Tension force, I say tension force is F1. I say tension force is F1. Then they have given time period is capital T. Now, how do you find this tension force? How do you find tension force? This tension force can be found by using which law? Reply. We learned. How do you find this tension force? In terms of, let's say, spring constant is simple key. Just think that spring constant is simple key. When you say spring constant of the string is simple k, how do you find the tension force F1? If not T1, tension force T1, we can apply what? Hooke's law. Hooke's law equals F equals Kx. Hooke's law equals F equals Kx. Then we can use Hooke's law. Hooke's law. Hooke's law says that F equals Kx. Here K means spring constant of that spring or spring. X means extension, if not change in length. Simple X means extension or compression, if not we say change in length. Now, natural length of the string is simple r. When we connect a toy to one of the ends of the string, what happened? its length has increased by simple r. Therefore, extension is simple r. Extension is simple r. So therefore, we can write down tension force T1. We can say tension force T1 as tension force T1 equals K extension, increase in length, simple r. Simple r. Right? But they ask in the question, they ask, time period is given capital T, they ask that the car is then speed up until it's moving in a circular radius of 3 simple r. Now, when the speed is increased, now we know that when the speed is increased, then what will happen? Omega increases. When speed is increased, omega increases, right? Now, when speed is increased, omega increases. Now time period is changed. Now they are asking now time period. They mentioned now radius of the circular path is 3 simple r. Now radius of the circular path is 3 simple r. Radius of the circular path is 3 simple r. Then what is the extension? What is the increase in length? Natural length is simple r. What is the extension? Extension is 2 simple r. Natural length is simple r. Extension is 2 simple r. Then let's say now tension force T2. Now tension force T2. Now tension force T2. Centripetal force is tension force. Now centripetal force is tension force, that is T2. Then if you write T2, T2 equals K. T2 equals spring constant into extension. That means increase in length, that is 2R. 2R. That is 2R, equation 2. Then tension force T1 is KR, T2 is K into 2R. We want to find time period now. Now time period I say T dash, if not T2. So now time period I say that T0. Now I need to find the now time period. How do I find that? We apply always circular motion questions. We apply F equals M mean. Apply F equals M mean. Apply F equals M mean. So when you apply F equals M mean, when you apply F equals M mean, just apply F equals M mean for this one. For this case, then we can say that now F equals M mean. F means tension force. Tension force is KR. Tension force KR. F equals MA mass M mr omega square now. Because we want to find time period, therefore mr omega square. Now radius is 2 simple r. Omega squared. Omega squared means what? T equals 2 pi over omega. Omega squared means how much? Omega squared means 2 pi over capital T squared. 2 pi over capital T whole squared. That means 4 pi squared over capital T squared. Now, rather than writing all the steps, I wrote omega because we know that now. F equals ma. Here A means centripetal acceleration. Centripetal acceleration means r omega squared. Omega means 2 pi over capital T. The omega squared means 4 pi squared over capital T squared. That's what I have wrote here. I have written here. The equation 1. If you apply the same, if you apply F equals ma for this scenario as well, this second case also, then tension force T2, that is K into 2R. K into 2R equals M. Now radius is 3 simple R. MR omega squared. 4 pi squared. T not squared. T not squared. T not squared. Then you can easily find the answer. Then you can easily find the answer. How do you find the answer? Now you can say that when you divide equation 1 by 2. If you divide equation 1 by 2, we can say that equation 1 by 2. When you divide equation 1 by 2, we can say KR over K into 2R equals simple M. Normally, when you do MCQ, you want to reduce the steps as much as possible. But coming days, I will reduce. Now in paper class or everything, I just reduce and I do the steps. But here also, but we want to reduce the steps and we want to do MCQs. 2R 4 5 squared over capital T squared. Simple M into 3R 4 5 squared, capital T naught squared, capital T naught squared, capital T naught squared. Now you can get the answers here. Simple lim, R, 4 5 squared, 4 5 squared cancel out. Then here Kr cancel out. Then what is remaining? The remaining is T naught squared equals T naught squared equals T naught squared equals, then H2, if I bring this to H4, 3T squared. 3 over 4 capital T squared. Then T naught will be root 3. If I did the root in both sides, root 3 over 2 capital T. Did you understand? If you understood, raise your hands. If you understood, raise your hands. If you understood, raise your hands. Right, okay. Then question number 8, 2004 A level. 2004 A level. Now that question. 2004 A level. Two small objects. Question number 8, 2004 A level. It says that two small objects of equal masses are attached to each other by a light string BC, and this system is connected to a fixed point capital O with another light string AB as shown in the figure. Now somehow two masses connected to two light strings. The basic understanding is there are two masses. Those two masses connected to two light strings. I think capital B, we can say capital B is one of the masses and capital C is another mass. There are two masses connected to two light strings. Look at it. The masses are then made to move in horizontal circular paths of radii capital R and 2 capital R. See the figure with the same angular speed. Angular velocity of both the masses moving in circular motion are same, right? Both of them have same angular velocity. Angular speed means angular velocity, and both of them have same omega. A, B, and C are always in straight line, right? If T1, T2 are the tensions of the string BC and AB respectively, then they are asking tension ratio, equal masses. Look at it. Look at it now. There are two masses, capital A and capital B. There are two masses. Let's say there are two masses. Simple MC. I say mass of each object is simple M. There are two masses. Now both of them are having same masses. Both of them have same masses. Simple M, simple M. Simple M, simple M. Both of them have same masses. Simple M, simple. Right? Now then, these two masses are connected by two strings AB and BC. This is string AB. This is a string BC. Now what happens? Capital B now, if not simple, this simple M mass and both the masses moving two different circular motions. These two moving two different circular motions. Two different circular motions. Right? Two different circular motions. Then the thing is now, centripetal force now. When you consider this mass at point capital B, what is centripetal force? They mentioned that tension force on AB string is T1, tension force on BC string is T2, right? T1, T2 tensions on, sorry, T1, T2 are the tensions of strings BC and AB respectively. This is T, okay. T1 means tension force on BC string, tension force on BC string. Then, now, T1 means tension force on BC string. T2 is the tension force acting on AB string, right? Then any point on this BC string, tension force is T1. What is the tension force acting? What is the tension force now? When you consider BC string, if you consider BC string, what is the tension force acting on this mass? T1 this direction. Tension force acting on this mass, T1 this direction. When you consider AB string, tension force on this mass, that is T2. This mass moves in a circular motion. This mass moves in a circular motion of radius R. What's that? R. It's capital R. This mass moves in a circular motion of radius capital R. This simple M mass moves in a circular motion of radius 2 simple R. 2 simple R. Now the same idea. Now they are asking the relationship between T1 and T2. What you should do? Always you want to apply F equals ME. Always apply F equals ME. So when I consider this simple M mass at capital B, if I say simple M at capital B, simple M mass at capital B, I can apply F equals ME. When I apply F equals ME, if I apply F equals ME, what is the resultant centripetal force acting on this simple M mass? T2 minus T1. The resultant centripetal force acting on this simple M mass, T2 minus T1. T2 minus T1. T2 minus T1 equals simple M centripetal acceleration. Now they mentioned both the masses have same time period, right? Both the masses have same time period. If both the masses have same time period, their angular velocity also same, because T equals 2.5 omega. If both of them have same time period, their angular velocity omega also same, right? So therefore, I thought of use M, the radius of circular path of this one is capital R, omega squared, equation 1. When I apply for mass at capital C point, capital C point, if I apply F equals ME, if I apply F equals ME, then tension force, the centripetal force acting on this mass is only tension force. Centripetal force acting on this simple M mass is only tension force T1. Tension force T1, simple M, centripetal acceleration radius. What is the radius of circular path traveled by this mass? 2 capital R. 2 capital R. Centripetal acceleration 2 capital R omega squared. Both of them have same angular velocity omega. Equation 2. Now I need to find relationship between T1 T2. So therefore now I want to obtain a relationship between T1 and T2. So therefore somehow I want to eliminate simple M capital R omega. Therefore I divide equation 1 by 2. If I divide equation 1 by 2, I will get that T2 minus T1 over capital T1 equals mr omega squared over m2r omega squared. m2r omega squared. Omega squared, simple m, r cancel out. Then when I cross multiply, 2 capital T2 minus 2 capital T1 equals T1. Then minus 2 T1, that side 2 T1 plus T1, 3 T1 equals 2 T2. If I substitute T2, If I subject T2 equals 3T1 over 2. Raise your hands if you understood. Raise your hands if you understood. Right. That is also done. Then question number 9, that is easy. Question number 9, a sphere capital M attached to a thread is whirled in a horizontal circle at a constant speed as shown in the figure. The forces acting on the sphere observed by a person who is at rest in the laboratory are best represented by. Now, when someone is outside and when someone is looking at the circular motion of that particular object, he observes only two forces. Weight is downward direction, tension force on the string upward direction. Therefore, right answer is second one. Okay, that is second one. It's not difficult. Now, question number 10 is more biased to vectors. I will discuss 10 later. 11th one. Question number 11. Question number 11. A particle is moving in a circular orbit of radius 10 meter. A particle is moving in a circular orbit of radius 10 meter. At one instant, the speed of the particle is 10 ms minus 1 and is increasing at a rate of 10 ms minus 2. That means tangential acceleration. That 10 ms minus 2 means at that particular instant tangential acceleration. The angle between the velocity vector and the resultant acceleration vector of the particle at that instant is. Now look at it. Now look here. Now this time 2006 A level, 11th one. 11th one, 2006 A level. 2006 A level. 2006 A level. Now centripetal acceleration, tangential acceleration. Now we know that. We know that. Yeah. Now what is tangential acceleration? Is my particle. Now generally circular motion questions, most of the circular motion questions uh, just think about an object moving in a circular motion. When this object moving in a circular motion, we can say that a direction of tangential velocity at this instant this way. When this particle is somewhere here, its direction will be in this way. When the particle is exactly somewhere here, it will be direction of tangential velocity at this instant will be here. Suppose if this particle is somewhere here, direction of tangential velocity would be in this direction. Then we can understand that direction of tangential velocity changes. We know that direction of tangential velocity changes. Direction of tangential velocity changes. Therefore, there will be a resultant acceleration because whenever there is a change in velocity, because we know that velocity is a vector. Velocity is a vector. If direction changes, so if magnitude changes, velocity changes. Now just think about that. Now just think about that. Magnitude of the tangential velocity. Now only think about magnitude of the tangential velocity. Only think about magnitude of tangential velocity remains constant. V, 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 V. Even though magnitude of the tangential velocity remains constant, direction of tangential velocity obviously change as the object moves in a circular motion. So therefore, there will be a resultant acceleration always to the center. Am I correct? Due to the change in direction of tangential velocity, there is a resultant acceleration to the center. That's what we call as centripetal acceleration. That's what we call as centripetal acceleration. Right? Then what is this tangential acceleration? Then what is this tangential acceleration? Centripetal acceleration AC. Tangential acceleration means, now here I only considered magnitude of the tangential velocity remains constant. But sometimes when object moves in a circular motion, not only its tangential direction, but also its magnitude of the tangential velocity also can be changed. Suppose in a circular motion, magnitude of the velocity, magnitude of the tangential velocity also changes, then there is tangential acceleration as well. At this particular instant, tangential acceleration direction will be in the direction of tangential velocity. At this instant, direction of tangential acceleration will be in the direction of tangential velocity, this direction. That is my AT tangential velocity. Now they have given that 10 ms minus 2, that is tangential acceleration. Tangential acceleration is 10 ms minus 2. Now they mention tangential velocity 10 ms minus 2. Tangential acceleration 10 ms minus 2. They have given tangential velocity 10 ms minus 1. They have mentioned V equals 10 ms minus 1. And now we can easily find the centripetal acceleration. Our centripetal acceleration equals, as they mentioned, as they given tangential velocity, we can say V squared over R. V squared over R. V 10 ms minus 1 10 squared. Circular motion radius. Radius is 10 meters. Radius 10 meters. Radius 10 meters. Then I'm getting centripetal acceleration as 10 ms minus 1. Centripetal acceleration also 10 ms minus 1. 10 ms minus 1. Right? So then the summary now. Centripetal acceleration is also 10. Tangential acceleration is also 10. 10. Tangential acceleration is also 10. Then the resultant, then what is the resultant acceleration of both? The resultant acceleration of both will be passing through in this direction. What can you say about this angle? If both of them, if centripetal acceleration and tangential acceleration, both of them have same value, then this angle is 45 degree. In 45 degree, in the question they asked, angle between the velocity vector and the resultant acceleration vector of the particle. Velocity vector at this instant upwards, resultant acceleration vector this direction, this angle is 45 degree. Answer is 45 degree. Answer is 45 degree. Now question number 12. Now 12th one. Question number 12. Figure shows the space colony of radius 1000 meter. Figure shows the space colony of radius 1000 meter rotating about its axis. At what angular speed must the space colony be rotated so that an astronaut standing in the flow of the colony experiences a push on his feet that equals his weight on the earth? weight on the earth. Now it's very easy now. This time now someone reply now there is some kind of space colony because in future sometimes there will be many space colonies. I don't know that. Now a space colony now it's rotating with an angular velocity of omega. Now there's an astronaut. He's standing on that standing in the flow of the colony, right? Now tell me now the space colony also rotating, then the astronaut moving in a circular motion, astronaut moving in a circular motion, right? Then tell me that this time, in order to move in a circular motion, this astronaut also moves in a circular motion. What is the centripetal force this time? Now, what is the centripetal force? This time, which force is the centripetal force? Reply. Now, astronaut moves in a circular motion because of which force? Now, this time, which force acts as centripetal force? Reply. Which force acts as centripetal force? Reply. Not this time friction. This time normal reaction. This time normal reaction. Do you understand? This time astronaut because of the normal reaction force. Look at it. Now it is an astronaut, right? Now in the space you want to understand there is no gravitational field, right? You need to understand that one also. Then this time, when you consider circular motion of this astronaut, because of the contact between the legs, feet, and the flow of the space colony, there will be a normal reaction force to the center. Because of this normal reaction force, this astronaut moves in a circular motion. Then we can say that F equals mv. This time F is r, m, centripetal acceleration we can say r omega square, r omega square, mr omega square, mr omega square, mr omega square. Now they mentioned that this normal reaction is equal to weight of the person in the earth. That means mg, mg, r equals mg in the earth because weight of the person in the earth is mg. Now this time is r must be equal to mg loop. Then mg mr omega square, cancel out, g is 10, r is 1000, omega squared, sum of omega will be 0.1 radian per second. Is the answer. Raise your hands if you understood that question. Raise your hands if you understood this question. Understood? If you understood, raise your hands. Raise your hands if you didn't understand. Raise your hands if you didn't understand. If you have doubts, ask in the class. Then that is also done. 2008, 2012, 13. Okay. Now remaining, now we'll stop from here. We discussed roughly 1.5 hours. That 3:30, 3:30. Then we'll stop from here and again whenever I'm free, most night times or day times, I don't mind these days. We'll discuss remaining in different day. Okay. Okay. I'll stop the class right now.